Okay, so this is basically the, this counts the volume, and this counts the number of degrees of freedom. And for each degree of freedom, we have to multiply by kBT, right? So if I do this, then I have L cubed will cancel L cubed. What we also want to do is that we want to go from here to d nu, okay? So if I do this, okay, this thing and this thing is going to give me 8 pi, and this thing is going to give me, so there's another 8 here, so we get 8 pi cubed, and then we have k squared dk. So dk is 2 pi by c d of nu, and k is going to be 2 pi nu, 2 pi nu squared divided by c squared, right? C squared. So here we have 8, 8. So we get this thing, and then this pi will cancel one of these things. And so we have 4 here and 2 here, so we get 8. And there's a pi squared here and the pi in the new denominator, so we get 8 pi. And here we have c cubed. And then we have nu squared. I forgot my kBT here. And then I have kBT times d nu. Okay, so this is the energy density. Okay. All right. And this formula is called the Rayleigh-Jeans formula. So what is the total energy that is, what is the total energy density that is radiated over all frequencies? Well, that should be just U integrate, where we integrate from 0 to infinity of d of u nu d nu, right? So here we should get 8 pi c cubed kBT, and then we get nu cubed by 3, and our limits are infinity to 0. And obviously this is divergent, but see that the divergent comes from the upper limit of the formula, right? Of the integral. So therefore we see that this is the ultraviolet catastrophe. Okay. Okay, so this is the ultraviolet catastrophe. And if I now draw the, the experimental curve, which was something like this, right? And this was lambda, and this was u of lambda. Then what the ultraviolet catastrophe is going to, if you, so this formula is actually given in terms of frequencies, but you can convert it into you can convert this thing. So this is the density. You can convert this in terms of lambda. And that's an interesting exercise that you should do. And if you do that, you will find that for high, low frequencies, it agrees pretty well. But as the frequency increases, it diverges from this graph, and it just goes to zero, infinity. So that when you integrate the area under the curve, you get an infinite amount. Okay. So this is the ultraviolet catastrophe. And I think we're out of time for today. And in the next class, we will discuss how Planck found its resolution. Okay.